Hi, this is Jack Rind, and I'm going to be talking about a new automated logic module that we are implementing called enthalpy-based reset controls. So for some context, we wrote this control strategy to help streamline the HVAC operation of a nationwide portfolio of properties. So as you go across the country, indoor conditions in an area such as Arizona might feel much muggier and hotter in an area such as Florida. This makes rolling out a corporate standard for HVAC impractical. This automated logic module is even more beneficial for properties like retail that don't have a facility engineer on site. These types of properties typically have to deal with HVAC issues through a ticketing system where they might not get resolved for a day or two after. Additionally, the current pandemic has placed an even greater emphasis on indoor air quality and maintaining a healthy one. So these controls will help keep the relative humidity within the optimal range of 40 to 60% to aid in virus mitigation. So for the concept of enthalpy-based reset controls, enthalpy can be defined as the total heat content of a space, including the temperature of the air and heat stored in a water vapor, which is where humidity comes into play. How the logic module works. It automates the resets of the effective set points of the air handling unit to maintain a set enthalpy of a space taking the humidity into account, or until effective set point bounds are reached. So to illustrate this on a psychrometric chart, the red solid line going diagonal here represents the enthalpy, which is set. The dotted vertical red lines represent the effective set point bounds, and the curved horizontal black lines represent the relative humidity. So as relative humidity increases, the set points can be lowered to maintain that same enthalpy. As relative humidity decreases, the set points can rise and maintain that same enthalpy value. So the benefits that we're seeing in high humidity locations. First and foremost, occupant comfort, because rather than a reactive adjustment, waiting for an occupant to file a ticket, these are proactive changes. So where this also benefits, number two, it saves time. Occupants usually have to file these tickets and then work with the tech company once they arrive to help resolve these issues. In this case, they're already being addressed. It also reduces maintenance. It saves truck rolls from occurring, techs having to show up on site, inspect all units, maybe to just make a set point adjustment themselves. And then third, and most importantly, it has the potential to save energy. So the system will restore the set points to the standard as humidity decreases. This avoids overrides that are forgotten about or persist past the desired end time. In addition, occupants have the tendency to overcool a space when doing a manual override, making a 4 or 5 degree adjustment where a 2-degree adjustment might suffice. So this increases the precision of those adjustments. Benefits in low humidity locations. The effective set points in these situations would rise to maintain the same enthalpy value. The benefits that we see here, air handling unit compressor run times are reduced as set points are increased. This reduces the equipment life cycle costs, but most importantly, it saves energy. In cases where we've already done this manually, we've seen 3 to 7% reduction in the daily electric usage. In times where the humidity was lower, we made these 2-degree set point changes ourselves at 27,000 square foot retail stores, and the effect is illustrated below on the load curve. You can see in this case, it ended up being a 5% reduction in their daily electric consumption. That is how we're going to make use of enthalpy-based reset controls to improve occupant comfort and optimize operations under dynamic conditions. Thanks.